Hey guys, we're in something a little bit different today. We're in a two-door Hemi with a 6.4 engine, and this Jeep is a manual transmission, and yes, this Jeep is owned by a lady. She wanted to upgrade her cooling system, so she had a heavy-duty radiator put in, but she was still running off the old 2-speed fan, which really wasn't hacking it in this 6.4 Hemi that's blacked out here in Las Vegas. So we installed a Pentastar fan, and unfortunately it wouldn't work with the TIPM because of the programming that's going on with the Hemi. And we see other customers that are in situations like this where they're trying to run a Pentastar or a Camaro fan in a hot rod, a vehicle without a CAN bus, there's no controller, whatever. So we actually build our own fan controller, and that's what I want to talk about today. This fan controller can run either a Pentastar or a Camaro fan. Now the Pentastar and the Camaro fan run at different hertz, that's frequency, so they're not interchangeable. But our controller is switchable between the two hertzes. The module also has an input for automatic transmission temperature and AC condenser pressure. So you'll have to run a transmission temp sensor if you want that part to be functional, and if you want it to cool for AC condenser pressure, you're going to have to run a AC pressure sensor, or a pressure transducer as they call it. With these three inputs, that will pretty much take care of most of your cooling needs. It's not going to change the cooling fan based on vehicle speed, but that's not really a big deal. We're running a manual transmission in this, so we're not running the automatic transmission sensor. But you can see going up the parkway here, it's kind of a hot day. Let's see. That's 95 degrees out. We're running 200 degrees with the AC on, so that's not too bad. If you're interested in running a pulse width modulated variable speed fan in your build, whether it's a JK or a hot rod, we will be offering this module soon. It's pretty easy to hook up. It's just basically power ground, signal out, and then whatever inputs you choose to support. While I'm talking about the fan controller, let's talk a little bit about these fans. Early JKs ran a single DC brushed motor. It wasn't sealed. For its time and for what it did and what it cost, it did a pretty good job. But water and dirt could get in there. The fan was relatively powerful. It ran a 17-inch blade. It was a DC brushed in runner design, so it didn't have as much torque as the variable speed fan motors. It ran 2 speeds by using a voltage divider, or a lot of you call it the fan resistor. So basically what it would do is it would take system voltage and drop it down to about 8 volts, and that would give you your low speed. That's really an economy way of Chrysler doing a 2-speed fan. If you look at some of the better 2-speed fan motors, they actually have 2 sets of windings, one for high, one for low. They can be wound so that both work at the same time, or just one set of windings. But the bottom line is, if you lose one set of winding, usually a 2-speed fan that has 2 sets of windings will continue to run, where if the JK fan motor burns up, you're stuck. When we step into the Pentastar fan, we went to a variable speed, pulse width modulated outrunner, which means the outer stator turns, and you can't think of this exactly like a DC brushed motor where you just apply voltage, and the more voltage that you apply, the higher the kV, or the higher the fan speed. These motors are electronically speed controlled. They have a module that does that. Very similar to like a model quadcopter speed controller. So running the outrunner design means the outer part of the can turns, which means we have more torque. Having more torque means we can make the motor flatter, so the variable speed fan motor assemblies are usually thinner, which helps in the JK because we don't have a lot of room, and it means we can turn a larger blade. So we're turning a 19-inch blade with both the Pentastar and the Camaro SS fan, and they're putting out significantly more volume than the early fans. When it comes to control, that can be tricky because these fans really are variable speed, which means there is no one speed. And they have multiple inputs: transmission temp, intake air temp, coolant temp, vehicle speed, AC pressure, etc. So OE manufacturers obviously program their fans to run at whatever speed they want. But sometimes it can be difficult to drive these aftermarket fans when you don't have an OE computer doing it. So what a lot of the early Hemi guys would do, and even the late Hemi guys, is they just run these Pentastar fans wide open all the time, which can be really annoying, especially if you're trying to talk in the vehicle with the windows down. We've never done that. We've always modulated the fan. With our Camaro SS fan, it's fully integrated into the GM operating system, so the fan just shuts off when it's not needed. In some ways, I like to run the evacuation mode, as I call it, where we run it at a really low speed. You can't even hear it, but that does tend to keep air moving through the engine compartment, so when the engine does start getting warm, it's easier to cool it down quickly. And it seems to also lead to more consistent temperatures rather than the up and down that the discrete fans had. Discrete fans mean they're on and off. So basically there's a hysteresis where the fan turns on and it runs at a pretty powerful speed until the temp drops below a certain temperature and then it turns off. So you get this cycling up and down. Variable speed fans, on the other hand, only run at the speed they need to get the job done, whether that's condenser pressure or coolant temperature. So the variable speed fans only run as much as they need in order to get the job done. We don't like to run them at full speed because it's annoying. We do run the Pentastar fan at about 30-40% with our LS conversions, and there's a lot of reasons for that in the operating system. In addition, the Pentastar fan has a negative coefficient hertz, which means basically the lower the hertz, the faster the fan goes. And that's really not the industry standard. If you look at the new JL and the LSs and the LTs and all the other fans out there, they pretty much run higher hertz, higher kV. Because of that, we have to run the Pentastar fan at a low speed. When you take a Pentastar and or Camaro SS fan and you retrofit it, whether it's a JK that's fully integrated through the can or in a 69 Camaro that's a hot rod build with an LT, it really is one of the best fan choices out there. Our new fan control module is going to help you get that fan in, because we know a lot of you have been struggling to try to find a proper fan control, and it can be difficult because different manufacturers run different hertz, different duty cycles, so these controllers really are not that interchangeable. Now, many of you may not know, but the fan is actually controlled by the TIPM. Some people call it the central gateway, but the bottom line is it's that fuse block thing on the passenger fender. What the TIPM does is it gathers information from throughout the vehicle. It gets air conditioning, pressure, vehicle speed. It gets engine coolant temperature from the electronic control module, or the ECM. In this case, it's a PCM because 2011. So we have a powertrain control module which also controls the transmission if it had an automatic, but this has a manual. So once the TIPM gathers all the information it needs, it then puts an output out. And the TIPM can be programmed for pulse width modulation, discrete 1 fan, discrete 2 fan, etc. So with a early JK like this, it's obviously set for discrete 2-speed. And it has 2 relays, one in the TIPM for low speed, and then a high power relay under the headlight bucket, the driver headlight bucket, for high speed. So essentially the TIPM just grounds the triggers on these relays, which then applies voltage to the fan motor and you get your speeds. The low speed fan circuit on an early JK goes through the voltage divider, which, like I said, splits the voltage down to about 8 volts and then only runs 8 volts to the fan motor for the low speed. So it's quieter and you don't hear the fan screaming when you don't need to. The high speed relay basically just goes straight through to the fan and gives you that high speed. Now, one of the issues with the early fan control is that this power is supplied by the TIPM. It's not going directly to the battery. That's a lot of amperage. We could be pulling 20, 30, 40 amps on startup. So that power had to go through the TIPM. One of the big improvements they made on the Pentastar as well as the SS fan is they run the power and ground with heavy duty cables right to the battery. That way we're not running all that current through electronics. It's just going straight to the battery, and all we have to do is drive a signal wire, which is simple to do in one way and not simple to do in another way, because that signal wire output is based on input, and all of you know that garbage in is garbage out. So we have to process that information, put the proper signal out, that is the proper duty cycle and hertz, voltage, etc. So that's what we're going to test today with this JK. Our temps are staying pretty stable. We're going to hit the mountain, we're going to go up some steep grades with the air conditioning blasting, and we will see you in the next video.